Hello, we're not in the car today or the man cave, we're in, well, the man kitchen. And this is because my tripod of 20 years has finally given up the ghost. It's very sad, so it makes filming in those places quite difficult indeed. Anyway, today we're going to talk about emulation. Now if you don't know already, emulation is the replication of hardware in software. And it's great for the one-lone coders out there because it is a fusion of all things that are a bit geeky and nerdy. You take old retro games consoles and you can replicate how the processor works at the logic level and the circuit level, and then try and write really optimal code to make it a working machine, a virtual machine on your desktop or laptop or phones even now. But as well as being a fantastic nerd exercise, it also has a useful part in the history of computer gaming. It will allow us to maintain a legacy of the old games. The hardware is going to stop working, we're not going to be able to get hold of it anymore. How do we play the old classics? Now, I dug out my Game Boy here, which was, I got this when I was about 12 years old, and it's the transparent one. Obviously I needed that one because I wanted to see how it works. I can see the electrons moving around inside the thing, I can see the code doing its business and providing the sheer joy on the very low resolution dot matrix display. But transparent was definitely the way forward, and they don't make things transparent anymore, and I don't know why that's the case. So this was my Game Boy, and it stopped working, and so I needed to upgrade it with my Game Boy Color here, which wasn't as good in as many ways. But one of the things Nintendo got right is that I could take my cartridge from the original Game Boy and plug it quite happily into the new hardware, and it would still work. Brilliant, I could still play the games. Emulation replaces hardware. It is a completely software concept. Using my transparent Game Boy as an aid, we would take a model of the CPU and we would model the memory and we model the buses and we construct all of these as software entities. We model the sound chip, we model the graphics memory, although I don't believe the Game Boy actually really does anything particularly clever with a graphics chip. And we model the buttons, the start, stop, A and B, sorry, start and stop, start and select, A and B, up, down, left and right. And the cartridge just contains a ROM, a read-only memory of the game. This contains basically the program and any sort of additional data information, so the musical notes of part of a song or the sprite information to display on the screen. So one way of preserving this game is to extract the ROM from the chip inside this. You can do that with quite a few different tools. You can take the chip off the board, plug it in and tear out the bits one by one. You can read from the ROM. And once you've got the ROM in a digital form, your emulation software can use that digital ROM to play the game, to emulate the function of the entire system. Perfect. But, and this is where emulation becomes a bit tricky, it's very murky legal waters. I own this game, but do I own the software that's inside it? The answer to this is not black and white. And this is only going to get more complicated with digital downloads going forward because you never really own the software anymore. You own a license to, well, basically rent the software until you get rid of it, and then you've got to buy it again. And perhaps a little rightly, the big companies aren't that pleased about people being able to take the software off these things and distribute them very simply and easily around on the internet. They're not getting any money for their property, their intellectual property. And it will have cost them, well, perhaps hundreds of thousands of dollars back in the day to make these sort of games, particularly this one, Zelda DX. So why should they be expected to give it out for free now? And of course Nintendo have jumped on this. They've released the Virtual Console for the Wii and the Wii U, and I presume it's coming out on the Nintendo Switch too, where you can basically get the ROMs. And they recently got into trouble with the Nintendo Mini Classic because somebody looked at the ROMs on this little console and found out that they were the ones ripped by the pirates in the first place. I believe that was for perhaps the Super Mario Brothers game. So I think the commonly accepted belief is that emulation itself is quite legal and acceptable, but the distribution of ROMs is not. And I think a lot of emulation websites will also tell you that before you can download anything. Which I don't recommend, and that's one of the reasons I'm starting this video with a little bit of a diatribe about emulation and Game Boys, because my last video was doing a first-person shooter at the command prompt, and it occurred to me that, well, I've got basically 4 shades of grey here. Have I got any consoles that have 4 shades of grey and a reasonably low resolution? Well, yes, I've got my Game Boy here, which is 160 by 144 pixels, each different LCD grey level, with only 4 of them. Can I make an emulator that runs in the console? Well, yes I can. Must confess, I've not written the emulator for this bit, but I have adapted one that's already out there. And just so I don't get into trouble, the only games I'm going to be emulating are the ones that I physically own. So I've got Tetris here for the Game Boy, I've got a transparent Mario Golf, again it's transparent, we can see the software. I've got Zelda, Link's Awakening. Now these are the two Game Boy Color editions. I won't be doing Game Boy Color emulator at the command prompt just yet. I've also got some others if we get around to trying them. V-Rally, James Bond 007, which is quite actually better than you'd think it is, and Donkey Kong Land, which is superb, but I don't think we'll get that one to run. That one has some additional graphics malarkey, I believe, going on inside the cartridge. And I think this one I got free on the front of a magazine once. It's Pinball Mania. Yes, awful. So just how easy is it to get a Game Boy emulator working at the command line? Well, let's have a look. Before I start delving into the code, just show you that firstly, yes, it is possible. Here we go. So we've got the console set up to showing a 160 by 144 array of characters, and what's really nice, I think, is that the Windows command prompt anti-aliases the font at this resolution because it's so the characters are so small, and it makes it look like individual pixels. Yes, the aspect ratio is a bit skew-if, but you know what, it works quite nicely. So I'm going to press start here. I've mapped the keys on the keyboard to the emulator buttons, and we'll choose yes, go, 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 and it's Tetris. But there's no sound with this emulation, so you know, ding, 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 ding. There, that'll have to do. That's enough. And the emulation's quite nice. So let's see how it's done. So the first thing I'm going to point out is I have not gone and coded an emulator in the space of a week. Although as much as I'd love to go and code an emulator, I've actually did a quick Google search for an open source Game Boy emulator and found codeslinger.co.uk. He's done a whole bunch of emulators. He, she, I'm assuming it's a he, but anyway, they have done a whole bunch of different emulators. And if you click on Game Boy here, we can see some little screenshots of what their emulator can provide, and it looks like it can emulate quite a lot of games nice and accurately. Good, we'll take that. The nice thing to note here is also, if we're doing these sort of little hacks of other people's code, is how easy is it going to be to interface, and all we can see is the emulator is just a display, so that's quite nice. That means somewhere there'll be a memory which represents these pixel colours. We can probably definitely get into that, and hacking the buttons in is probably not that difficult either. But this site, I mean, all credit to codeslinger.co.uk, whoever you are. It's a really nicely laid out site where he talks about all of the different aspects of emulating this system, and you can look at the hardware, how the hardware works, what the buses are, what are the opcodes, and I did find there was a nice document somewhere on here. That's it on the first page. If I go to this gameboy.pdf, which is looks like a bible of how the Game Boy works, and this is proper nerd porn as its absolute dirtiest. It's fantastic. We've got hex addresses, we've got bits and opcodes and extended opcodes, and we have to think about DMA and how all of the words are structured to do something interesting. It's really, really good. What a fantastic resource put together by a obviously dedicated community of programmers. Anyway, going back to the code, all I've done is downloaded CodeSlinger's code, and the first thing I did was create an int main where for the console. You'll notice I'm not pulling in any particular libraries, and all my int main does is a direct copy of their int main. However, CodeSlinger's int main works using the winMain function. Mine, because it's a console, we're not going to have that, so I've done exactly the same. I've started the Game Boy emulator here, and that calls this function, which loads a ROM of the cart that we wish to emulate. In this case, you saw it was Tetris. Now, there's some couple of changes you need to make. The first thing is the CodeSlinger's original code used OpenGL and the SDL libraries to interface with the user. This isn't an option for us, so I'll just quickly run through the changes that we've made. There's a function here called create SDL window. You can see it had the original SDL code in here. I've got rid of that, and all I'm doing is creating a screen buffer, as I did with the first-person shooter engine. And it's exactly the same code, and all I've done is set the resolution to be window width and window height, which are variables provided by CodeSlinger anyway. So I'm trying to keep it within CodeSlinger's code base. The next change that needed to be made was SDL was using SDL timing events. I ditched those and just used the good old-fashioned clock function. It's good enough for this purpose. And I also got rid of the SDL hardware inputs and replaced those with get async key state, which you'll have seen from my code your own synthesizer videos. This looks a little bit jumbled up here, but it's basically the hex for the arrow keys and Z, X, A and S, and they've been mapped into the same key space that CodeSlinger had theirs mapped into. And all it does is if a key goes down, it calls CodeSlinger's set key pressed and set key released. It's one of the things I like about this source base is that it is quite accessible for hacking, and the code is nicely presented too. So one of the things that we'll need to do is display stuff, and if you go into the rather large emulator.cpp file, I found in the function, well, I was just scanning the code and thought, oh well, hang on, I see something here related to colors: white, light grey, dark grey, and presumably black. And we can see the values that the pixel memory are being set to in this case, so red, green and blue, but of course it's a black and white console effectively, so you set them all the same for the grayscales. And here in the render game function in the gameboy.cpp file, I have just simply replaced this OpenGL magic, which drew a texture based on the manually created memory space from the emulator file. And all I looked for was the same values, so I'm just running through all of the pixels individually and setting my console buffer output to magic Unicode characters. So this was a fully shaded one, this was a half shaded, 25% shaded, and black. And I threw in this one just in case something interesting pops up where we end up with a memory value that we don't understand. It'll display an X, although I've not seen that yet. And it does exactly what it does in the first-person shooter. It just blasts it out to the console screen. So you've already seen the Tetris game running. I'm going to change that to the ROM I've got of Zelda Link's Awakening, and we just compile and run. Let's see what happens. So this is the intro credit sequence. That's nice. You see it's running at a sensible frame rate. That's because we use the clock function to make sure everything runs at a known time, similar to how we got the smooth movement in the first-person shooter for the console. So if I press the start button, we can skip the intro. Create a character. Yes. Oh, let's press A. Perfect. Yeah, let's go. And there we are, so that's the start of the Link's Awakening game. So it looks like a very solid emulation. What a relief. Well, let's try one last game. I wanted to see if we could get that Donkey Kong one to work, and this is not a criticism of CodeSlinger's emulator at all. This is more due to, see, it seems to start, but I believe that the game was complicated enough to warrant some of its own interesting hardware in the cartridge, which I guess doesn't get emulated. So if we press start, see, it kind of it looks a bit murky. Press start again, select for the game. It's kind of there, it's working. It's a little bit difficult with the fidelity, but that's not really the problem. So you can see they've got Donkey Kong quite happily and a coin spinning, but there's all sorts of artifacts around the graphics. And as we start walking, oh no, it's all fallen apart. So there you go, with perhaps only maybe 20 lines of additional code changes to codeslinger.co.uk's excellent emulation, you can have your Game Boy emulator running in the console should you want to. Right, if you've enjoyed this video, give us a thumbs up, perhaps subscribe, or go to the onelonecoder.com blog, follow me on Twitter, all the usual stuff. Just keep on coding and have fun. See you next time.